Hello everyone, welcome to Baozi Training Leetcode solution. If you want the best mock interview experience in North America, feel free to check us out at baozitraining.org. And also if you want to get the latest technology news or interview tips, feel free to subscribe to our WeChat account right here. Okay, so today we're going to talk about this problem, permutations 2. So unlike permutations 1, permutations 2 can have duplicate elements. So whenever we're trying, and then this problem wants you to print out all the unique permutations. So as long as the problems has kind of like a duplicate case, so the first thing comes into mind should be set. So, but if you still remember, for permutations 1, the method we have is basically during our DFS recursion, we keep a list because everything is unique. For example, if we have like 1, 2, 3, so we use a list to check if the element already is in the list. So then we will just skip this element. We want to add other elements. So one way to solve this problem, actually for problem 1, is so it's also like recursion, but it's just a different way. Like we could build a recursion tree. I haven't really mentioned it in the previous video, but for example, so first you add 1, right? And then you have this intermediate result, intermediate list, which only contains 1. And then when you add 2, so you could add in front of 1, which becomes 2, 1. And you can add this 2 after 1, which becomes 1, 2. So then your intermediate result, list of lists, contains a 2, 1 and 1, 2. And now for 3, so essentially you can have, I guess I have to 3, 2, 1. This is one solution. And then 2, 3, 1, 2, 3, 1. And then you can have 1, 2, 1, 3. So for this case, you could have 3, 1, 2, 1, 2, 1, 3, 2, 1, 2, 3. So basically, in that case, you will have 6 results. However, here, if we have instead of 1, 2, 3, we could have like 1, 1, 2, like our example. So let's say 1, 1, 3. So essentially, all the 2's will be replaced by 1. So now you could see the problem really becomes to, see, this first 311 and this 311 will be a duplicate. But essentially what you can do, you can have a set of list of integer. So because in this list, if you have 1, 2, and 1, 2, the set will basically help you dedupe. And then at the last, your final result, you can just add all the elements in the set so that you can have the final result using the same method. So this is also a very decent method. However, for practicing point of view, so I think this problem is more like do not want you to use set because then that becomes too easy. So they want you to basically to kind of skip the elements like during your recursion. So the idea is also very simple. It's like whenever you have this element, when your first time when you do the recursion, you will just keep doing it. However, whenever you get out of the recursion, so for example, if you get out of this one, so the next element naturally should be this second one. However, if you do the second one, then do it again, so then there will be a dupe. So the idea is when you push the second, when you first finish the recursion, so you want to basically skip all the elements that are equivalent to the previous element. So for example, if you get out of the recursion, so you want to skip, 1 is equal to 1, so I should skip the second one so that I don't have dupe, and then you move to the second 2. So that's basically the idea. Skip the duplicate. Okay, so because this is also regarding complexity, this is also listed all the result set. So this will also be a O(n) factorial time complexity and O(n) factorial space complexity. Okay, let's code it up. Just like usual, validation checks. Now, so first thing you want to do is basically to sort the array so that you can easily to skip the values. And now what you want is basically a helper method helps you to so you need an intermediate result list, you need a final result. Right? Let's see. So in this case, your helper will looks like takes in a so uh-oh. Then okay, so unlike the permutations 1, here I need to know whether this is the one element is visited or not. So how do I know that? So I could know that by visited so whenever you visit an element, if this is already visited, you want to skip that. And now, if it's not visited anymore, so you want to add this element. And now it keeps your recursion. And after you jump out of the recursion, and now you want to skip the element whenever you jump out of the recursion. So basically for I is less than n minus 1, because I want to compare the elements afterwards it. So I plus 1 has to like this, and then I just keep doing it. I think that will be it. So let's take a quick look. So first to check the if it's null or empty, sorted, length default to false. So if it's just only one element, in this case I sort it, I put it here, so length is just equal to 1, not visited, added, and then jumped out of this loop, return, one element is fine. So 1, 1, 2, so I have this, what is this n? I don't know. And here, so less than the size, and then I keep going. Okay, I think it's correct. All right, so here it is. Thanks for watching.